Ready? On? All right.
Yeah.
All right. Caleb, here we are while you are stressing out on that test. And we're having a good time studying our next chapter on random variables. We started with the definition of a probability model. There are two parts to a probability model. And we learned that on that chapter that you're taking a test on right now. It has to have an outcome. It has to have all the outcomes listed, and it has to have the probabilities of each outcome. And we would know if it was legit or not. If they added up more than one, we'd say, If one of the probabilities was 2, it was negative. So we talked about that last chapter. Today we are going to look at a type of probability model called a random variable. So we're going to have two parts to the random variable. A chance event has to occur, and a variable has to be assigned to various values that hook to this event. So we did an example. We did flip the coin 3 times, and we picked the random variable to be the number of heads. Here's the outcomes that have 3 heads. Here is the outcome that has 3 heads. Here are outcomes that have 2. Here are outcomes where x is 1 and 0. So from there, I'm going to take a look at what's called we're going to look at the random variable again in chart form, because usually they're not written out for you like this, but you'll see where the numbers come from in the chart. So let me get rid, I'm out of tissues, so I'm stressed. So I have to use an eraser. Okay. What's that? They don't count. They're not plus. They're no better than an eraser. Alright, so I want you to make this little chart for me. And this is going to be the random variable x. And we're going to look at its value, 0, 1, 2, and 3. You see where that came from all our example where we actually did the flips of the coin, and all the possible outcomes of the number of heads are 0, 1, 2, and 3. But what are their probabilities? Alright, so a lot of times the author of this text will give you the probabilities. On this one, since we have all the outcomes, let's calculate them. So Elena, you started out with the heads, and there was 3 of those. What's the probability of getting heads when we had how many possible outcomes? 8 possible outcomes. 1 out of 8. So, all right. So, Elena's the probability. Put that in the wrong category. It's for 3 heads. All right. So, Julia, yours was the 2. So, what's the probability of these situations?
3 out of 8.
2 out of 8. And I'll go ahead and I'm sorry. No, this could happen 3 times.
Okay,
Yeah,
I said 3 out of 8.
3 out of 8. Okay, I'm sorry.
Okay.
And Bailey, what was yours? How many times can we get 1?
3 out of 8.
All right, and 0. Allie?
1 out of 8.
1 out of 8. All right. So is that a good problem? Is that legit? Is that a legit probability model? So the way we do that is we check and see if they add up to 1 and they are acceptable. Brandon, does it work? They do add up to 1, and there's no illegitimate probabilities there. No negative ones, no strange ones greater than 1. So it does pass. So what we have here is a chart of a random variable. We are going to change that now to an old dear friend of ours called a histogram. When we change it to a histogram, we no longer call it a histogram. Of course not. Why would we do that? We're going to call it a probability distribution. But all it is a histogram. So we're going to change this chart into a histogram. That's what your problems will be like today. You'll be given this and asked to do this. So make sure you watch and see how it's done. All right, along the horizontal axis, we're going to have the values, I'll call them, or outcomes. That's where the 0, 1, 2, 3, 0, 1, 2, 3. And along the other side, we're going to have the probabilities. So in this case, we only have, what, 1/8, 2/8, and 3/8. There's no 2/8, but I need it on the chart. So if we make a histogram, how many times, what's the probability of getting 0? The bar will go up to 8. For 1, it'll go up to 3. For 2, it'll go up to 3 again. And for 3, it'll go up to 1/8. So that's a probability distribution for this chart, for this random variable. So we are going to have to be able to come up with that. Go ahead and copy that down. Is that pretty clear? If I gave you a chart, could you make one from it? I think it's not too challenging. So if I give you a chart and I'll say this random variable has a probability distribution. Draw the histogram for me. That's what I'm looking for. So let's look in general then what we have looked at. We're going to have values for our random variables. So say our variables is x1, x2, x3, etc. And we're going to have our probabilities. See how this is just a probability model. We have values, we have all the outcomes, and we have their probabilities. So it's nothing new. This would be probability 1, probability 2, and probability 3. So I've just given you a chart that's general. You've seen a specific one. So this is a chart in general. Why I gave you the general one is to make some notes. First of all, these probabilities, I don't know how many there are because I put ... They all add up to 1. And each one is between 0 and 1, just as probabilities are. So you can see we're not hitting it out of the ballpark here. We're just kind of reviewing things and looking at another angle of this. Now, notice here. I'll wait for you to catch up with me. I wonder how long we've been recording.
We still have like 5 minutes.
Think so? Okay. All right. Get a timer going too. Timer's set for 12, so next time you start it. I don't like to get too close to 15 minutes. Anywhere below that, you think. All right, what happens here, if I pointed the arrow to a strange spot right between the two values, x1 and x2, it's like right between 0 and 1, or 1 and 2. So why would I be interested in the spot in between the values? And that's just to make the point that there is no in-between values. So it's not like we could have 1.5 heads. So no in-between values. So when that happens, we give that a special name. It's called discrete. That means we can't have 1.5, 2.5, 1 3/4. There's nothing in between the two values. It's either a 1 or a 2 or a 0 or a 3. These are the possibilities and nothing in between. So therefore, we call this whole section discrete random variables. Random tells you again that you're having a chance event, and variable is the one that's taking on several different values, depending on what the random chance event is. So So all I did is I added the word discrete, and that means there's no in-betweens. So let's look at an example and on your handout where it's talking about Apgar scores. Do you see that? Do you see the little baby? Right after a baby is born in America, maybe everywhere, I'm not sure, at least here, they are assigned by some health professional an Apgar score. They look at the baby immediately after birth and they determine its responsiveness to some sort of stimuli. I think they take it, have you ever seen that response where you take a newborn and you just barely touch its feet to the ground? Do you know what it does? If its toes just barely touch the surface, it goes like this. It's amazing. It's like it knows how to walk, but it's just born. But if you hold the newborn and their feet just barely touch a surface, they'll start like this. So they'll do that walking motion. Of course, they're not supporting any weight, but they go through it. That's part of the responsiveness test. The skin color, the heart rate, the muscle tone, and the breathing. And from that, they get a score, I think, from 0 to 2 for each of those categories, so you can get as high as 10. So you're assigned, isn't that awful? You get graded the moment you come out of the womb. So are you used to it by now, getting graded? All right, so are we still on part 1 of the video?
Yes.
Okay, do you think it's about time?
I mean, we still have 50 seconds left.
All right.
But I can stop it now.
It's a good start. Stopping. Start.
Bye.